Okay, last problem. Pretty exciting. A single burst rocket is launched from ground level straight up. With what initial velocity must it be launched to reach a maximum height of 2048? We've done this problem a bunch of times. H of t equals negative 16 t squared, because our units are feet, plus our initial velocity, which we don't know, times time. No constant term because it's launched from the ground. So we have that, and then we have v of t, the derivative of the height function, giving you the velocity function, has to equal, using the power rule, negative 32 t plus v naught. So we get a system of equations by saying the maximum height, which was 2048, 2048 equals negative 16 t squared plus v naught t. That t now represents the time it takes to reach the maximum height, and at the maximum height we know the instantaneous velocity is 0, so 0 equals negative 32 t plus v naught. So v naught equals positive 32 t, which we will substitute in right there. So we get the equation 2048 equals negative 16 t squared plus 32 t squared, because v naught is 32 t, and 32t times t is 32t squared. So then 2048 equals positive 16 t squared. So divide by 16 on both sides, gives you 128 equals t squared. So t will equal the square root of 128. So if we want our velocity, we need to multiply that by 32. That's what that says. Initial velocity is 32 times this t value. So v naught has to equal 32 times the square root of 128. So crunch that number, get an approximate value for it. So that approximate value is 362.039 feet per second. So there's the answer to A. But B says, what time will the rocket hit the ground? Well, if you think about this, all we really need to know to answer that question is that time we found, because this is launched from ground level, so it's going to have an x-intercept there. It's a parabola, so it's going to have perfect symmetry. We found that this time right here was the square root of 128, which means that this time right here when it hits the ground is 2 times the square root of 128. So that's all you have to calculate to find this answer. 2 times the square root of 128 gives you t equals 22.627 seconds. Now, that is only true because this object was launched from ground level. If it started at 5 feet off the ground, that method we just used would not work. You would need to graph the equation with the v naught plugged in, and you would need to calculate the x-intercept and then find that corresponding time. But since it's launched from ground level, that's our answer, and party time. You just finished probably the biggest math study guide of your life. You're going to do a great job on this final because you've been working very, very hard. Go you.